Welcome. In this segment, I will discuss the definition of elasticity of demand and look at one or two of its basic properties. Elasticity of demand looks at how a 1% change in price affects the demand. In other words, what's the percentage change in demand caused by a 1% change in price? Use of percentages basically discounts the units. The percentage means that no matter what the units are, you will get the same number. Mathematically, we can analyze this in the following fashion. Suppose the price increases from P to P plus delta P. The demand will change. Let's say it goes from Q at a price point of P to Q plus delta Q, price point of P plus delta P. Of course, delta Q will be negative. Let's not worry about it right now. Then we look at the percentage changes. For the demand changed by delta Q. So the relative change is delta Q over Q. The percentage change is 100 delta Q over Q. Same way the percentage change in price is 100 delta P over P. The ratio is the elasticity of demand for that change. So this is 100 delta Q over Q divided by 100 delta P over P. You can cancel the 100, do a bit of algebra to rewrite it. We get P times delta Q over Q times delta P. We want to have delta Q over delta P, which is a difference quotient as a fraction by itself. So we rewrite it yet again as delta Q over delta P divided by Q over P. Again, you can use simple algebra to verify these two are equal. So this is our definition of elasticity of demand for the whole interval. So average elasticity for that interval. When delta P is small, when you're making small changes in price, we can approximate delta Q over delta P by dQ over dP. So we can approximate the elasticity of demand by dQ over dP divided by Q over P. This is somewhat similar to instantaneous rate versus average rate of change. For elasticity of demand, it's called the point elasticity of demand because it's as if we are looking at elasticity of demand at a single point on the demand curve rather than over some interval. We will, following the textbook, use eta to denote the point elasticity of demand. So formula for eta is eta equals dq over dp over the fraction q over p. We assume that the demand equation is given in the form q is a function of p, but often we also have price given as a function of q. So we want to rewrite this formula for that situation. Dividing by q over p is same as multiplying by p over q. So eta is p over q times dq over dp. It turns out that inverse functions are derivatives which are reciprocals of each other. So dp over dq is a reciprocal of dq over dp, which means multiplying by dq over dp is same as dividing by dp over dq. This gives us our alternate formula for eta. Eta equals p over q divided by dp over dq. Of course, since p and q move in opposite directions, one decreases when the other increases, the derivatives will be negative, so eta is also negative. Some people use absolute value. We will follow the textbook and keep the sign as it is. So the meaning of the point elasticity of demand is that if you change the price by 1%, then the demand changes in the opposite direction by eta percent. If you change the price by some percent, the demand changes by eta times that percent. It means that if eta is bigger than 1 in absolute value, so eta is between negative infinity and negative 1, 1% increase in price depresses the demand by more than 1%. We say the demand is elastic because apparently the demand is not constrained by other things as much, and so price plays a bigger role in the decision to buy that good. This is often the case for luxury goods. We can live without diamonds or fur coats, so if the price is more than we can afford, we don't necessarily buy them. If eta is less than 1 in absolute value, then price changes don't have as much of an effect on the demand. So essential goods generally fall into this category. Even if they're giving away milk for free, we are not going to start drinking a couple of gallons of milk a day. On the other hand, there is a floor for the consumption of milk. People like drink milk. It's considered part of a healthy diet, especially for children. So the demand doesn't go down to zero very quickly. This concept, elasticity of demand, can also be used to look at how price changes affect revenue. So if we calculate dr over dp, which is somewhat similar to marginal revenue, dr over dq, you can use the product rule. R is pq. So d of pq over dp is, first factor is p, its derivative is 1, so we get 1 times q plus p times dq over dp. And if you look at the formula for eta, one of the things we got was that eta equals p over q dq over dp. So p dq over dp is q times eta. So we get that dr over dq is q plus q eta. Factoring out q, we get q times 1 plus eta. If the demand is inelastic, means eta is between -1 and 0, 1 plus eta is positive, so dr over dp is positive. Basically what happens is that if you increase the price, the demand falls, but not as much, smaller percentage decrease than in the price. So the price increase more than offsets the decrease in demand, so revenue overall increases. So the demand is inelastic, 1 plus eta is positive, so q times 1 plus eta, or dr over dp, is positive. So with inelastic demand, price increases increase the revenue. If the demand is inelastic, so eta is between -infinity and -1, q times 1 plus eta is negative, so dr over dp is negative. Price increase causes a bigger percentage decrease in demand, so the demand decreases more than the price increases. They don't offset each other, so the overall revenue decreases. If the elasticity is exactly -1, unit elasticity, that means small changes in price don't affect the revenue much at all. And you'll see what this means in the next chapter. So I will stop here. In the next segment, we will look at some of the calculation examples. Goodbye for now.